Alrighty, everyone, welcome to day 21 of Advent to Code. Getting ready here, down to the last few days left. The monkeys are back. You're worried they're going to try and steal your stuff again, but it seems like they're just holding the ground and making various monkey noises at you. Eventually, when the elephants realize they don't speak monkey and comes over to interpret. Oh, you don't speak, okay. As it turns out, they overheard you talking, trying to find the grove. They can show you the shortcut if you answer their riddle. Each monkey is given a job, either to yell a specific number or to yell the result of a math operation. All the number yelling monkeys know their numbers from the start. However, the math operation monkeys need to wait for the two other monkeys to yell a number, and those two other monkeys also be waiting for on another. Those two monkeys. Okay, your job is to work out the number the monkeys named. Remember, the monkey named Root will yell before the monkey figured it out themselves. Okay. A colon, and then the job of that monkey. The lone number means that monkey job is simply to yell that number. The job, like A plus BB, means the monkey waits for A and BB yell K. Okay. Has to wait for monkeys that yell number. Okay, then the monkey. So it sounds like we're building a. Sounds like we're gonna be building a tree. Fun. Cool. So. Tree time. So it's not too hard. We just I guess the first thing we do is just build monkeys and just go through it that way. If you have a math operation, yeah, first let's convert each line into a node, I guess. Yeah, so what we're going to need is we're going to need private class. This is going to be a node again. I'm calling these nodes because that's the only thing I can, just the easiest. And so we're going to have a list of nodes, and this can be done recursively. That works. I guess this could be called monkey. Sure. Well, if I could spell monkey correctly. Okay, array list. So what's going to happen is the monkey is going to either have a math operation or it's going to have a number. So public abstract, this is going to be get value. So this is going to be an abstract class because we're going to need a monkey number and we're going to need a monkey operation. So what this is going to be is public get value. This is easy. Okay, so the monkey number is going to be simply public int number, and it's going to return number. This one is going to have public monkey left, monkey, this is left. I could make it be a string, but we'll save it. Yeah, we can make each monkey do it that way. So we're gonna have a public, public string ID. Let's call it ID. It's fine. So there's monkey left. There's monkey right, and there is a char op. So we're gonna do a switch. So we need int left val equals left dot get value. We're gonna need the right value, and then we're gonna need a switch on op. case that it's a plus. This is simple because we just do left value plus right value. We can return this. I think it's actually this, right? That's how you do enhanced. Let's do left. Okay. Minus multiplication division. Multiplication division. Okay. There we go. So now we have monkeys. So we have all the monkeys. So now we can actually go through and do this. So for string s in inputs, go ahead, create a monkey. This is where we're going to get a little bit weird. This can actually be a hash map, make life easier. Make life a little bit easier. We're gonna need monkey equals new. What we're gonna need to do is we need to determine which type of monkey it is. Let's just get. We can use length. We can cheat this. Is length greater than 8? If s dots length is greater than 8, we can cheat the system. New operation, monkey operation. Oh, this is not abstract. Oh, I didn't extend monkey. There we go. Monkey.id is going to be equal to, should we do string id is s dot substring from 0 to 4. They're all 4 letters. Okay. And we're going to skip the operation part because that can come in a second. Do one pass, get all the monkeys, create our map here, and then we'll go through again and do the actual operation of this calculation. So put ID and monkey, and this is going to be a monkey number. Make life easy. Okay, and then we're going to do this one more time. Yeah, that actually makes that a whole lot easier. Okay, try this again. So now we have ID, and now we have this bit. So now we know we have a monkey operation. So we actually can do is here do monkey equals monkeys get ID. Okay, so we have our monkey, and so now for length is greater than 8, so now we have the operation. This one's easier. I guess there are 2-digit numbers. But either way, 6 plus, so it's going to be monkey as a monkey number equals integer parse int. I can actually make this better. We can just go 10. We'll do 10. To do 10 to be safe. Parse int of s dot substring of, I said 6 plus, right? 6 plus. So that one's good. So the operation is 6 plus. So string, let's do this, val, string left ID is going to be equal to val substring 0 to 4, and then the opcode will be at 6, right? 1, 2, 3, 4, 5. Sorry, 5, 6, 7 on. Right. Okay. This is char at. And so now we can do is monkey operation. Monkey operation is monkey, cast it, and left is going to be equal to monkeys get left ID. Same thing for right. And monkey operation op is op. I can simplify this to be that. Make life a little bit easier. Probably simplify all of these. Okay. So now we've gone through. So now we have our monkeys. So now what we need to do is simply just do lap of monkeys get root and get value. And if I did this right, in theory, I should have made these all longs. Try this again. Hey, let's go. Top 1,000. All right. Not bad, not bad. Some kind of monkey, elephant, human mistranslation. You seem to have misunderstood a few key details with the riddle. First, you got the wrong job for the monkey named Root. Specifically, you should go... Specifically, you got the wrong math operation. The correct operation for monkey root should be equals, which means that it still listens for two numbers from the same two monkeys as before, but now checks that the two numbers match. Secondly, you got the wrong monkey for the job starting with... it isn't a monkey, it's you. Oh, it's human. Actually, you got the job wrong too. You need to figure out what number you need to yell so that Root's equality check passes. So what number do I have to yell for that? So... Okay, so wait, where is this? Okay, I understand this. So what we need to do is we need to figure out what we need to yell. We're at a quality check, right? Oh, we need to know. Okay, so root is an equality. Okay. So what we can do is we can do monkey operation root equals monkeys get root. Make life easier. So what I can do here is I can do int left equals, or I can do long left equals root left get value, long right equals root dot right get value. And for now I can do system dot out dot print line left right. So this could be as simple as just brute forcing. So if I do monkey number human equals monkeys get what was it? This one. Human dot number equals 1. Do this again. What numbers change? Do they both change? Just the left changes. All right, well, I say we brute force this. Let's just give it a shot. So while left does not equal right. You know what? Brute force it is. How bad can it be, right? Okay, it can be pretty bad. It can be pretty bad. Okay. Is it at least going down? It is at least going down. Okay, so it's a relatively large number. We're just gonna like I'm honestly gonna brute force this. What if I did split difference? Or like, you know, the guessing game. So, so low, long equals, long, high. Okay. So split the difference. So what if I do is, because we start more then. So what we can do is we can do human number equals low. Right? This is how it works, right? Because you do... Yes, but you don't do that. You do high minus low divided by 2. And then what you do is you do if left is greater than right, that means we need to increase the low, because it's that. So we do low equals val, right? Else if that, we do now high equals val, and this just continues on, right? Quick maths. Oh. No, low. What did I mess up here? What's messing up? Left is greater than right, so low equals value. High minus low. It can't go any lower. Oh wait, because I did this math wrong. It's not this. It's the midway point. High minus low. Plus low. Do you get the distance between the two? Yeah. Right? That was quick. No? Actually, I should check this. But that gave me... Wait, that was right. What? But if I yell that... Huh? I'm so confused now. What? But that makes the sides equal. How is that not my number? Okay, so what if I take the example in here? What I get if I use the example? Oh. Oh, these must be, it must be flipped for the example. $301. So this is gonna fail because it's gonna go the wrong. Oh. Oh. Wait, if I do that, and put this back to this, will that fix it? Yeah, okay. Yeah, 301. So this is going to fail because it's going to do that whole, yeah, wrong circular thing. So I need to do this because they're flipped around, right? I know it's just for mine specifically, but how is that not my answer? How is that not my answer? I get them, they're the same. out of curiosity. Yeah, it's gonna go on forever. I don't understand how that's not the answer. What the heck? I got a different number. Wait, there's multiple numbers? Wait, what? Are you kidding me? There's multiple numbers? Dude. I guess I just need to find the smallest number. Which I guess is this one. Huh. 417, not bad. How far was I from the leaderboard? 16 minutes, that was pretty far. If equals right. I wonder. High minus low plus plus. Will this give me my right answer? This does. Okay, so it did have to do with the high and low weren't there yet. I don't know if this is the right logic, but this gets me there at least. Okay, well. I'll take it, I guess. So make sure it's the same. Yeah. Okay, well. Fair enough. Let's go over the solution here. Let's talk about this. So today's problem is not too bad, honestly. It comes down to building up a kind of a tree of sorts. That way you can recursively call this and have it solve its own math problem. So our input is a list of monkeys, each monkey having an ID, and each monkey having either a number assigned to it or a math operation assigned to it. If it has a math operation assigned to it, it is then also given to other monkeys to which it needs to do that math operation on. So the way you solve this is, I do this in 2 passes. I do my first pass, which is simply to go through all of the inputs, grab the ID of this monkey, and just grab the ID. Don't worry about the math operation or what the number is, just grab the ID, create a blank monkey object. We can determine if it's going to be a math operation or a number by the length. That's what I did, just a little quick hack. Obviously it's not great, you shouldn't really be doing magic solutions like that, you should make it a little more dynamic, but for the case of this problem it works. So because of the length, I do know if it's a math operation first or yelling a number. And so for that, we correctly construct a blank monkey operation or a monkey number, assign it to monkeys, and then just do that for the first pass. The second pass, then we actually fully parse out the input. The reason why I do 2 passes is because the first pass just makes sure that we have all of the monkeys and IDs assigned to it. That way we can reference monkeys even though they kind of haven't been parsed, so to say. In that case, you can see here, if we were to parse this line in one go, we would have this BLWT monkey, but we have not parsed DLGR or HRMN yet, so we have no idea how to reference them. We can't tell this one, the left, your left operation is this, the right operation is that, because they don't exist yet. But if we've already done a first pass, we've already gotten a list of all the monkeys or IDs and a blank object, we can now say, okay, hey, this monkey operation, here's your left monkey, here's your right monkey, and here's your operation. You'll do this operation in the future. Obviously, all of them haven't been assigned yet, they haven't been populated yet, but in the future, when we call a method, you'll have the monkeys you need. And in the case for if it's just yelling a number, we just assign the number there. You can see here, here's the base monkey class. All it has is a get value method and an ID. If it's a monkey number, we also have a number. That number is simply just returned in get value. If it's a monkey operation, they have a left and a right monkey. That's the operations, the left operation and right operation, or left number and right number, and then the operation it is. Because again, these are referencing monkeys, we need to get the value in order to actually get the value of this. We simply get the value of the left and right monkey, find the operation we need to do, and then do the operation on the left and right value. And then we can return that get value. So the solution for part 1 is simply just to get the root monkey by getting the ID of root, and then simply calling get value on root, and that'll bubble down all of the tree. It'll basically go down the full tree, getting the value of each monkey, bubble up the answer, and then we have our part 1. Part 2, now the complexity is that we have HUMN, or human. That is not a monkey, that is us, and we have to yell out a number. We don't know what number we need to yell out. How do we know what number we need to yell out? Well, the root number, or the root monkey, doesn't actually do an operation. What it's doing is actually checking equality. And so what we can do is we can do a brute force, so to say, a brute force on this, and we can simply change what number we say until we get the left and right numbers for the root monkey to be the same. We can continually change our number, recalculate the left and right values for the root monkey, and if they're equal, we have found our number. If they're not equal, we haven't found the number. Now, you could brute force this and go from 0 to whatever. My answer is this big number, quadrillions maybe, I don't know. But it's a big number. You're not going to do that in by going up by increment of 1. So we can take a fast approach to this and do a binary search for that number. The way binary search is that you have a low bound and a high bound. We started at 0 and some relatively high number. And what we do is we split the difference. So if you ever play higher or lower, you always know the best way to play that is to do a binary search and to say, all right, if it's a number through 1 to 10, let's guess 5. 5's wrong, let's guess, or if 5 is low, let's guess 7. 7 is too low, let's guess 8. 8 is right, there you go. Or if 8's too low, guess 9. Binary search, you don't want to go through 1 through 10, it's really inefficient. We do the same thing here. We take our high number, subtract off the low number, split that in 2, and then we add in the low. That way we get the middle of our current bounds, set our guess to be that number, then calculate the left and right node, left and right values for this. If our left value is higher than our right, again, this is very specific to us, but if the left value is greater than the right value, we now know we need to adjust our low to be equal to value. So move up our, basically eliminate everything that is lower than our value, because anything lower than our value is just going to give us a greater left value. Again, this is where it's becomes specific to my solution or my question. These could change, but for me, if we get a left value greater than right, we need to basically eliminate all of the lower half of this range, just focus on the upper half. But if left is less than right, well, now we need to eliminate all the higher of our range and simply set high to equal to val. But we do get to a point where we get the numbers that are all returning the same value. So we need to make sure we get high and low down to one specific number. So that's why we have this else here. So if we do get left is equal to right, we're not done yet because we do need to get the lowest value. We do need to get the singular value. So I don't think this is quite right, but this works for my problem. So that's all that matters. But there you go. And then simply I'll put our number that this executes, and that's it. That is day 21 complete. Not too bad. Only 35 minutes to do the problem, explain it all and whatnot. But anyways, thanks for being here. We only have 22, 23, 24, 4 more days to go. So hopefully you guys have been enjoying this year's problems, this series. Thank you all for watching. Please hit the subscribe button if you have been enjoying this. But anyways, I'll see you guys all tomorrow for day 22. Peace out.